Welcome back to the deep dive. We're here to cut through the noise, get past the marketing speak, and really understand the tech shaping things.
That's right. Straight to the core ideas.
And today, we're diving into a pretty big shift in how video gets distributed, especially in commercial spaces. Think modern high-res video.
We're talking a 4K 30 hertz specifically, and AV over IP systems. Our sources focus mainly on WolfPack's approach, their build your own HDMI over IP matrix.
Right. The idea being you can customize these systems completely. It's a move away from those big old fixed matrix boxes.
Exactly. And our mission today is really to unpack the tech that makes this possible. Total scalability, custom setups.
And you look at the price, like the sources mention a starting point around $250 for components. That feels like it changes the game.
It absolutely does. It's not just a technical shift, it's financial, like you said. Makes it much more accessible.
So, okay, that's the core idea. For years, you needed a big matrix, you bought a 16 by 16, maybe only used 10 output.
Wasted ports, wasted money, proprietary hardware often too.
So what is the fundamental difference with this AV over IP thing? How does it get rid of that waste?
It really comes down to elasticity, flexibility.
Yeah.
You hit the nail on the head, no more wasted resources. In the IP world, the system size is just based on the number of endpoints you buy.
Yeah.
Your transmitters for inputs, your receivers for outputs.
So you're only limited by the network switch, basically.
Pretty much. If you need, say, 14 inputs and 32 outputs tomorrow,
Right.
you just buy those specific units. 14 transmitters, 32 receivers.
And if you need more later.
You just buy more units, maybe upgrade your network switch if you need more ports. That ability to scale up or even down is the big advantage. You only pay for what you need today.
That modular approach, yeah, it definitely feels like the future. Okay, so let's talk about the building blocks, the hardware. The sources mentioned something clever about the TX and RX units.
Yeah, this is quite neat. The 4K PoE transmitters the encoders, and the 4K PoE receivers, the decoders. They're actually the same physical box.
The same unit. How does that work?
You just switch its function using PC software. Tell it whether it's going to be an input or an output.
Huh. I can see the logistics win there immediately. You don't need two different part numbers on the truck.
Exactly. Grab a box, decide on site.
But hang on. If they're dual purpose, doesn't that potentially make each unit a bit more complex, maybe slightly pricier than a dedicated transmitter or receiver? Is that flexibility worth it?
That's a fair question. And maybe there's a tiny cost increase per unit for the components, maybe. But the savings in inventory management, that blows it away.
Okay.
Think about an integrator stocking hundreds of these, cutting 2 product types down to 1. It simplifies ordering, storage, and importantly, handling spares or replacements. That operational efficiency is huge.
Yeah, I get that. Makes sense. Okay, connectivity. We're sending video over a network, so standard network cables, right?
Correct. Just good quality twisted pair, CT6 or TT7.
And the distances.
They're pretty solid.
Yeah.
You can push 4K 30 hertz up to 450 feet if you're using TT6 or CT7.
450 feet, okay.
Or it drops to about 300 feet if you stick with just KD6. And the sources do recommend using STP-868B type cable specifically for the best video signal integrity.
Got it. And a big part of this is PoE, power over Ethernet.
Oh, absolutely. PoE is massive for simplifying installs. No need for AC adapters plugged in behind every TV or near every source device.
Right. Power comes right down the network cable from the switch.
Exactly. Much cleaner, fewer points of failure. They do include optional 12-volt adapters if you need them for some reason, but PoE is definitely the way to go for professional setups.
True matrix switching, too. Any input to any output.
Yep, it's a true matrix, any source to any display, or you can send one source to all displays simultaneously. Unlimited inputs and outputs, really. It just depends on your network scale.
But, okay, relying completely on the network for power and signal. That does introduce a different kind of vulnerability, doesn't it? Compared to maybe an older, dedicated box.
It does. That's the trade-offs.
Yeah.
You gain flexibility, you gain scalability using standard network gear.
CATS gear, yeah. Commercial off the shelf.
Right. But if that network switch goes down or if it's not configured correctly...
Your video system stops. Dead.
Exactly. So the reliability and, crucially, the configuration of that network switch become paramount. Which brings us to the network itself.
Okay, let's get into that. You mentioned scalability. The sources say the system keeps bandwidth under 1 gigabit, even for 4K. Why is staying under 1G so important for the cost?
This is key to the whole strategy. Keeping the bandwidth per stream low enough so the total bandwidth doesn't exceed 1G means you can use standard, affordable, 1 gigabit managed Ethernet switches.
Which are everywhere and relatively cheap.
Precisely. If each 4K stream needed, say, 2.5G or even 10G, the cost of the central switch would just explode. You'd be into much more expensive enterprise-grade gear.
Yeah.
Staying at 1G keeps the network infrastructure costs right down.
Makes sense. But okay, sending lots of video streams over IP, especially multicast one source to many screens, you need to manage that traffic, right? Otherwise, the network just gets flooded.
Absolutely. And that's where IGMP comes in. The sources specify you need a 1G IGMP PoE switch.
IGMP. Can you break that down? Why is it essential?
Sure. IGMP stands for Internet Group Management Protocol. Think of it like a smart traffic cop for multicast video.
Okay.
When a source like your satellite receiver sends out its video stream, multicast, IGMP lets the displays, the receivers, tell the switch, hey, I want to see that stream.
So the switch only sends it where it's actually requested.
Exactly. Without IGMP, the switch would just blindly forward that stream out of every single port.
Which would just swamp the network instantly.
Totally crush it. IGMP is non-negotiable. It ensures streams only go where they need to go, vital for AV over IP.
Right. That network intelligence is clever. Which leads us nicely into managing the system and this real-time preview feature. This feels like the big headline feature.
It really is pretty revolutionary for anyone managing a system day to day. It's the wireless real-time video preview. You use their app, XView, on an iPad or Android tablet.
And you see what exactly?
You see a live, full-motion video feed of all your connected sources, all at the same time on the tablet screen.
Wait, full motion, not just like static snapshots that refresh?
Nope. Full motion.
Yeah.
If you've got 12 DirecTV boxes plugged in, you see 12 little live TV windows playing on your iPad.
Wow. Okay, that's huge for troubleshooting, isn't it?
It completely changes the game. Think about the old way. A screen goes black. Is it the display, the cable, the matrix output, the source?
You'd have to physically go check things, patch cables.
Right. Or route that source to a known good monitor. Here. You just glance at your tablet. Video moving in the preview. Okay, the source is good, the transmitter is good, the encoding is working.
Yeah.
Narrows down the problem instantly.
Huge time saver. But let's be clear on the limits. The sources say the app previews video, but no audio on the tablet preview, right?
Correct. No audio in the preview itself. It's purely a visual confirmation tool.
And you can't use the app to, say, change the channel on that DirecTV box.
No, you can't. The app controls the matrix switching, telling input A to go to output C. It doesn't control the external source devices themselves. For that, you'd need a separate control system, like IR or RS-232 pass-through.
Okay. So the XView app is the command center just for the matrix itself.
Precisely.
And control isn't limited to just the tablet app.
No, you've got options. Besides the wireless tablet, there's Windows PC software, also called XU. And importantly for integration, there are RS-232, RS-485, and even basic I/O ports for linking with bigger control systems.
And the app control needs Wi-Fi, obviously.
Yeah, you need a standard Wi-Fi router connected into the same network as the AV over IP system for the app to find and control the matrix.
Makes sense. Okay, moving beyond just switching one source to one screen. Video walls. The sources say these units handle video walls internally.
Yes, and that's another big value proposition. Usually you need a separate, often expensive, dedicated video wall processor box.
Right.
This system has that processing built into the receivers, so you can create video walls of, well, pretty much any size. A 2x2 with 4 screens, a 3x3 with 9 bigger custom layouts.
And what can you display? One giant image across all screens.
You can do that, yes. One large, seamless picture. Or you can show multiple individual source pictures on the different screens within the wall. Very flexible.
Any mention of image rotation for portrait displays?
Yep, it supports rotation 90, 180, 270 degrees. Though, the sources note that rotation might be an optional feature, maybe depending on the specific firmware or model variant. Something to check.
Okay. And there's a limit on simultaneous windows.
When using the video wall function specifically, it mentions support for up to 16 windows on a single screen layout. So quite a bit of density possible there.
And the system does more than just video, right? KVM support.
Correct. It explicitly mentions built-in support for 4K 30 KVM, keyboard, video, mouse, so you can remotely control a PC from a receiver location.
That pushes it into control rooms, corporate settings,
Yeah.
not just bars and restaurants.
Exactly. Plus, it has that separate RS-232 capability we mentioned, and also dedicated audio extraction features we should probably talk more about later.
Definitely. Okay, let's get into the technical weeds now. Section 4, compression, protocols, resolutions. How does it stay under that 1G bandwidth limit with 4K video?
It uses standard, efficient video compression codecs. The system lets you choose between H.264 and the newer, more efficient H.265.
Okay, common codecs.
Very common, and highly effective at reducing bitrate. Plus, the audio handling it uses MPage 4AC or LPCM stereo is adaptive. It adjusts based on the available network bandwidth to keep the total screen size manageable and under that 1G ceiling.
Right, but hitting 4K under 1G usually means some compromises. The source mentions 4K 30 Hz, but specifically at 4.2.0 ALEO color space. Can you explain what that means for the picture? Is it noticeable?
Sure, 4.2.0 is about chroma subsampling. Basically, the compression throws away some color information while keeping all the brightness information. Compared to a full 4.4.4 signal, it has less color detail.
So, does it look bad?
For most typical commercial uses, digital signage, sports bars, corporate presentations, honestly, no. You probably wouldn't notice the difference. It's a smart trade-off to drastically cut the bandwidth needed.
But maybe not for high-end graphics work or medical.
Exactly. For color-critical applications, you'd want 4.4.4. But for general video distribution, 4K 30 at 4.2.0 is perfectly fine and enables that crucial 1G operation. Also supports 1080p 60 Hz and lower resolutions, of course.
How fast does it switch between sources? Any noticeable lag?
It's designed for fast switching. They quote, standard latency around 80 to 100 milliseconds, basically instant to the eye.
Okay.
But there's even a low latency mode mentioned, which can get it down to about 50 milliseconds.
Yeah.
That's really good for interactive stuff like KVM or maybe even some gaming scenarios.
Now, compliance standards. This got a bit confusing in the source material. It lists multiple HDMI and HDCP versions.
Yeah, this needs careful attention. It states it's HDCP 1.4 and HDMI 1.4 compliant. Those are the older standards.
Right.
But then it also says it's HDMI 2.0 and HDCP 2.2 compliant, which are the newer standards needed for a lot of modern 4K content, like from streaming boxes or Blu-ray players.
Which is it?
The implication is that it supports both, which would be good, offering backward and forward compatibility. But if you're an integrator, that's something you'd want to test thoroughly during setup to ensure it handles your specific sources and displays correctly with the required content protection.
Definitely worth double-checking. Okay, let's circle back to audio, because you mentioned a catch earlier, the de-embedding.
Yes, this is super important. The system does handle audio. It travels embedded with the HDMI signal from the transmitter, and the receiver unit has a 3.5 millimeter audio output jack to de-embed that audio.
So you can pull audio out the display location, feed it to local speakers or an amp?
Correct. But, and this is the key limitation, that 3.5 millimeter audio output is permanently locked to whatever video source is currently being shown on that specific receiver's display.
Meaning you can't do separate audio switching, like send audio from input 1 to the speakers connected to receiver 5, while receiver 5 is showing video from input 2.
Exactly. No independent audio matrixing. The audio follows the video, period. Receiver A's audio output will always be the audio for the video currently on receiver A's screen.
Okay, that's a critical distinction. If you need audio to follow different paths than the video, like in a complex bar or venue setup,
You need a separate dedicated audio matrix system alongside this video system. This box won't do audio fellow video switching or independent routing.
got it. Vital clarification. So wrapping this all together, the scalability, the control, what does a bigger system built with these components look like in practice?
Well, the sources give a good example.
Mm-hmm.
Imagine you need a 4K 12 by 32 matrix, 12 sources, 32 displays.
All right.
Using this system, you buy, 14 transmitters, maybe 12 for the inputs, plus a couple spares or for local loop outs.
Right.
Then 32 receivers for the displays, and the core tying it all together. Just one 48-port 1G IGMP PoE Ethernet switch.
One standard switch manages that whole 12 by 32 setup.
That's the beauty of it. You build these potentially huge custom systems using affordable network gear and only buying the exact number of endpoints you need.
That flexibility, relying on standard networking, cutting out the waste, it really does feel like the direction things are going.
Absolutely. It shifts the whole cost structure and deployment model.
So let's leave our listener with a final thought. Connecting this back to the real world, the day-to-day.
Yeah, think about this. How does that one feature the ability to see real-time, full-motion video previews of every single source on your tablet? How does that fundamentally change the job of managing and troubleshooting a big installation?
It goes from running around checking screens physically
To just looking at your iPad.
Yeah.
Remote verification instead of physical inspection. It speeds up maintenance, fault finding. It changes the operational demands completely. That, I think, is the hidden game changer in all these specs.